Okay, 8.2 is over the graphs of the other trigonometric functions. So we're going to start with tangent. So these still repeat just like sine and cosine, but they look a little bit different. So the trig function increases forever instead of doing the bump on the calculator. It's going to look like this. So it's kind of increasing, does a little inflection, and goes up forever. But it has asymptotes, so it's not always connected. The period of the trig function is pi instead of 2 pi. So that is one thing you want to pay attention to. And because it goes up forever, it has a stretch factor instead of an amplitude. And what we do with that stretch factor is we take the period, we divide it by 4, and that gives us a y value, which I'll show you what that means on the graph. But that's essentially this point. So the stretch factor is 1. It's halfway between a quarter of that period. The domain breaks every time we have that asymptote, which on the standard thing would be our pi over 2 or our 90 degrees. The range is negative infinity to infinity for tangent. So sine and cosine, that was the domain. Tangent, that's the range. And then the asymptotes are those breaks in the domain. The function looks the same. So it still has that a, b, c, d like before. We still find the period by dividing by the number in front of x. We're just doing pi divided by that now instead of 2 pi because the original parent period is pi. The stretch factor is the same as the amplitude, but because it doesn't really have a height, we just call it a stretch factor. So let's kind of look at these a little bit. When we're sketching a graph, what we do is, so we're going to find the same things. So our period, we take pi and divide it by the number in front of x. So pi divided by pi over 2 would end up being pi times 2 over pi. So that would make our period 2. And then instead of an amplitude, we have a stretch factor. So our stretch is the number in front, which is 0.5. This one doesn't have any shifts. So we're going to start with those two. So tangent, its middle is the origin. And then the period goes on half on each side. So if we say this was 1 and this was negative 1, a period of 2 would go 1 on one side and 1 on the other side. So we'd have half of each period on each side of that middle. For our stretch factor, we'd go in between those. So a quarter of the way. So halfway between the middle and 1, we'd go up 0.5. And halfway between the middle and the negative side, we'd go down 0.5. That's how that stretch factor works. Then we just kind of draw our shape almost like a cubic function. And if we wanted to repeat that, we would do the same 3 points over and over again. So let's look at another one here. So we get our period. We do pi divided by the number in front, so pi over 6, which would be pi times 6 over pi, which gives us 6. And then our stretch factor is the number in front, so 3. So if our period is 6, we would go 1, 2, 3 on one side, and 1, 2, 3 on the other side, and those would be our asymptotes. Tangent starts at the origin. The stretch factor is halfway between the middle and that period. That's how high we go. So halfway between the origin and 3, we're going to go up 3. So at 1.5, I go up 3. And at negative 1.5, I go down 3. So it's halfway between the middle and the period, which would be the asymptotes. And then your period is half on each side of midpoint. Then you just kind of go up the asymptote, connect those 3 points, and go up again. When it's really wide, it's hard to draw. You also could do those on the calculator. So if I did that first one, 0.5 tan pi over 2 times x, and then 3 tan pi over 6 times x. The blue one is going to be this up here. This is the blue one. And then the red one, zoom trig, yeah, is that, I think. Yeah. And if I zoomed on this one so that my window was -3 to 3, you can see this starts to curve a little bit. If I try -2, window, -2 to 2, or hold on, window, let me try here. Window, -4 to 4, maybe. Yeah, we're getting a little bit of curve in that red there. It's just hard to get the window right when that's such a wide period. So they're hard to draw sometimes. But it's just so you can kind of see where it goes. So that's how that tangent works. What's more important in this section is being able to find the pieces. You're not really going to have to draw them and sketch them so much as just being able to find the pieces of the equations and look at the graphs. All right, so now let's add in those other parts, the phase shift and the horizontal shift. So just like before, we're going to have to factor out this pi. So this would end up being pi plus 1 in there. So we have our period. We have our stretch factor. Then we have the phase shift and the vertical shift, just like before. So our period is going to be pi divided by pi, which is 1. Our stretch would be 2. Just keep in mind, because it's negative, we're going to be decreasing instead of increasing. Our phase shift plus 1 means we're going to go left 1. And our vertical shift is down 1. So that means our midline is going to be right here instead of the x-axis. Left 1 means instead of starting at the origin, we would start to the left at 1. And because the midline's down, we're really going to start here. If our period is 1, that means we're going to go 1/2 on each side. So if we've been using, let's say each of these, our scale has been 1, like 2 of these equal 1, so -1, -2, -3, like that. -4. So if our period is 1, then what we're really doing is half on each side. So from that blue dot, we're going half on each side. So that's how I use my period. And then my stretch is 2. So halfway between the dot and the asymptote, I'm going to go up 2 and down 2, but we're decreasing. So I do the opposite of what I normally would do. And then I connect those. And again, I would just use those same 3 dots over and over again if I were to be drawing multiple periods. So if you want to try to graph it, go ahead. If you don't want to graph it, at least find the 4 parts of this equation. So at least find the period, stretch factor, phase shift, vertical shift. If you want to try graphing, go ahead. Okay, so the period, because there's nothing in front of the x, the period is just pi. So we're actually going to leave these units as they are. Stretch factor is 3. Phase shift is left pi. Vertical shift is up 1. So because we're going up 1, I'm going to draw my midline here. And because we're going left pi, instead of starting on the y-axis, we're going to start here at that blue dot. Since the period is pi, I'm going to go pi over 2 on each side. So the period would be between those yellow lines. And the stretch is 3. So halfway between the blue dot and the yellow line, I need to go up 3 on the right and down 3 on the left. And that would be 1 period of tangent. And if I did it again, it would look like that. So because the period is pi and I shifted left pi, you can't even tell if you drew a whole bunch that it was shifted. So if you were to do this on the calculator, you would end up, or on the computer, you would end up with the same one. But like I said, I'm not asking you to graph them. It's more about finding these things. So now let's go in reverse. Find the formula for the graphed function. So first, we need to find all of the things. The period, the stretch factor, the phase shift, and the vertical shift. So period, how far between those asymptotes? So from -4 to 4 is 8. So the period is 8. So to get that for the equation, we would do pi divided by 8, which is pi over 8. Stretch, halfway between that, so from 0 to 4, which is at 2, how far up did we go? 2. So that would be the stretch. Phase shift, our middle's at the origin, so there is none. Vertical shift, the middle's at the origin, so there is none. So then we write our equation. Y equals 2 is our stretch. It's a tangent graph. Pi over 8, x, no shifts. Why don't you try this one? Okay, period. So if that's pi over 2, this would be pi over 4. So pi over 4 to pi over 4 would, if you add those up, would be 2 pi over 4, which equals pi over 2. So if the period is pi over 2, I'm going to do pi divided by pi over 2, which is pi times 2 over pi, which equals 2. The stretch halfway between the middle and the asymptote is right here. And if I go up, it looks like it's about 5. So my stretch would be 5. And the middle is on the 0, so it looks like there's no shifts. So y equals 5 tan pi over 2x. So that's the tangent graph. Let's look at secant. So as a refresher, secant is the reciprocal of cosine. So really what we're doing is we're taking the reciprocal of the graph. We're flipping the graph. So all x-intercepts are going to be asymptotes because you can't have 0 on the bottom. So I'm going to take this x-intercept. I'm going to make it an asymptote. So if you know how to draw a cosine graph, you can draw a secant graph. And then decreasing becomes increasing. So the next thing I do is I take all of those maximums and make them minimums. And all of the minimums and make them maximums. And then the blue is your secant graph with the asymptotes. That really is how that works. So you find information the same way you did for cosine. Graph the cosine graph and then flip it. So, period, amplitude, phase shift, vertical shift, and then we graph. So period, we would do 2 pi divided by 0.4, which 2 divided by 0.4 is 5. So we would get 5 pi. Amplitude is the number in front, 2.5. There's nothing added or subtracted in the parentheses. There's nothing added or subtracted at the end. So those are the same rules as if that was cosine. So we're going to draw this as if that said cosine right there for a minute. So I'm just going to pretend this is pi, this is 2 pi, 3 pi, 4 pi, 5 pi. Okay. So phase shift none, amplitude 2.5, cosine we start at max. So we'd start at 2.5 and we'd end at 2.5 because cosine we go max to max. And so at the middle, 1, 2, 3, 4, 5, 2.5, we'd have minimum. In between those, in between the max and the min, we hit our midline. So that would be, oh, that's 5. That's not 2.5. 2.5 is here. So that would be our cosine graph. And if I did it again, so 6, 7, 8, 9, 10. So that would be our cosine graph. Our x-intercepts become the asymptotes. And then we just flip our bumps. So the maxes become minimums, the minimums become maximums. And the red is the secant graph. That would be perfectly reasonable if it was by hand. Again, you'll be given the red graph and asked questions about it. You just need to be able to find this information, which is no different than finding it on a cosine graph. So why don't you try to find the information on here, and I will rewrite all of that. So period, 2 pi divided by the number. So 2 pi divided by 0.4 for this one was 5 pi. 2 pi divided by 2 is pi. Amplitude is the number in front. So this one was 2.5. It's the absolute value. So this one is 3. You would just go down first. So you'd min to min. And then nothing is inside, added, or subtracted for either. So there's no phase shift. Nothing is added or subtracted outside. So there's no vertical shift. If we were to draw them, we would start with the cosine graph. So this one's pi, so I'm just going to use the things that are here. So we'd start at 3, but we're going down. Min to min. Max is in the middle. Midline's halfway. Min to min. Max is in the middle. Halfway. That black graph is cosine. X-intercepts become asymptotes. And then your graph flips. So the red is your secant graph. So cosecant is the same thing, but cosecant goes with sine. So you find the period, amplitude, phase shift, and vertical shift for a sine graph. Draw the sine graph and then flip it. So period would be 2 pi divided by pi over 2, which would be 2 pi times 2 over pi, which would be 4. So 1, 2, 3, 4. Amplitude is the number in front. Phase shift is anything added or subtracted inside. Vertical shift is anything added or subtracted outside, so up 1, which means the midline's actually going to be up here. So I'm going to use that to draw the sine graph. So sine starts on the midline. And my period was 4, so it would start there and end there, and then hits that in the middle. We go up first, so up 2 from the midline, down 2 from the midline. So that's 1 period of sine. And I would do the same thing in the negative direction. I'm going in reverse. So there's another period. Intercepts, when you're on this, it's intercepts with the midline that become the asymptotes. So it's not necessarily x-intercepts, it's intercepts with the midline. Midline intercepts. So if you have a vertical shift, it's those midline intercepts that become the asymptotes. Then we flip our bumps. Because that midline still has to be the midline. So if you add a vertical shift, that green line still needs to be the middle of your secant bumps and your cosecant bumps. All right, so pause, see if you can at least find those 4 things. Try graphing it if you want to. So period, amplitude, phase shift, vertical shift. Period is, and notice on this one, the pi is already taken out, so we don't have to do any dividing. So the period is 2 pi divided by pi. 2 pi divided by pi, which is 2. Amplitude is 0.5, but notice it's negative, so we're going to go down first. Phase shift is right pi over 2. And my vertical shift is down 2. So my midline needs to be here. So if I were to put that in the calculator, let's just see what we got going on here. So negative 0.5 cosine pi x minus pi over 2 minus 2 zoom trig. So that's our cosine. So just if we did all of that, 1 divided by well, that didn't do what I wanted it to do. Never mind. Okay, let's do this. So 2 pi divided by pi. All right. It's 2. We're shifting right, pi over 2. So we're going to change these to 1, 2, 3, 4, negative 1, negative 2, negative 3, negative 4. We're shifting right, pi over 2. Pi over 2 is 90, or, well, okay. Pi is 3.14. Pi over 2, so we're going to start about here. 3.14 divided by 2 is 1.57. So 1.57, so we're going to start right here. And then we go a period of 2. So 1, 2. So that's our period of 2. And then we go down first. So there's our middle. And our amplitude is 0.5. Oh, but we need to be on the green line. 1, 2, middle. We'll go down 0.5, up 0.5. So that's one period of sine. And then I'm going to repeat it. So 1, 2, up, down. Just so we have a couple periods. Then midline intercepts become asymptotes, and I flip my bumps. So the red is our cosecant graph. And then the last one is cotangent. So same thing as sine, or as tangent. Find all the information for a tangent graph, draw the tangent graph, and then flip it. So period would be pi over 4. Stretch factor would be 3. So if I were drawing this one, I'd start here. If my period is pi over 4, I would go, geez, this one's going to be really small. Stretch factor is 3. So let's say if this is pi over 4, and this is pi over 2, and this is negative pi over 4 and negative pi over 2, a period of pi over 4 would be between those two yellow lines. And then a stretch factor of 3 would be between the blue dot and the yellow line. We'd go up to 3 and down to 3. This would be my tangent. To get the cotangent, your intercept becomes an asymptote, and your points reverse. So that blue dot becomes an asymptote. So I'm actually going to draw a few of these. So all of these would be points, points, points. And then the red lines are our tangents. Okay. So I need a different color. Let's do this color. All right. So the intercepts become asymptotes. So these are now asymptotes. And these go the other way. The asymptotes become intercepts. So all those yellow points now become the new intercepts. And we use those same green points in reverse. So now I'm going to go this way with my green points. And then the black would be the cotangent. I think I did that one backwards. Yep, this one will go like this. So your intercepts and asymptotes switch, and then you use the green points, you use your stretch points to reverse that. So let's look at another one that's a little bit easier to see. And it kind of does everything. Again, you're not going to be drawing them by hand. It's more about finding the things. So period, stretch factor, phase shift, vertical shift. Before we do anything, we need to factor out that pi over 8. So pi over 2 divided by pi over 8 becomes pi over 2 times 8 over pi becomes 4. All right. So my period is pi divided by pi over 8, which is pi times 8 over pi. So the period is 8. So we're going to go 1, 2, 3, 4. Actually, 1, 2, 3, 4, 5, 6, 7, 8. Negative 1, negative 2, negative 3, negative 4. Negative 5, negative 6, negative 7, negative 8. Stretch is 2. Phase shift is right 4. Vertical shift is down 2. So our midline is going to be here. All right. So normally tangent would start right here, but we're going right 4 down 2. So we're actually going to start our tangent right there. Our period is 8. So we go 4 on each side. So that would be 1 tangent. So if I did 2, I need a middle there as well. Halfway between the blue dot and the yellow, I go up 2 and down 2. So that red is the tangent graph. So now I switch my midpoint and asymptotes. So the asymptotes become midpoints, the midpoints become asymptotes. And then I use those same dots to draw my cosine. So I'm going to use the green and the teal to draw my cotangent. So the cotangent is that teal graph. So if I erased everything else, my cotangent is like the reverse of the tangent. So if it's alone, it looks like that. If they're all combined, it looks like that, with the tangent being the red, the cotangent being the teal. So that's how you graph the other ones. That is section